Lately I've had customers with carburetors saying they have injector problems or an injector flush, and I've had customers wondering if their car has carburetor problems when they're actually fuel injected. It's kind of backwards. So today we're going to do a video on fuel delivery or fuel injection or carburetors, things of that nature, the different fuel systems on cars. Let's get started. So like I just mentioned, I've actually had a customer schedule in a fuel injector flush, and when the vehicle arrived, it was carbureted. So this has happened quite a bit, so I decided it's time to do an instructional video and start from the beginning here. I do apologize. Right over here, we're next to the wall. It's snowed. There's a lot of snow melt going on, and you can actually hear the water dripping off the roof outside. So if you listen, you can hear it. Sorry if it makes you have to go to the bathroom. It's just the way it is. We'll be away from this here in a minute. This is an old tractor, and a lot of the technologies they used then started from Model Ts, some of the cars even before Model Ts, very, very basic single barrel carburetors. What's interesting about this tractor, which was the same in a Model A or a Model T, there's no fuel pump. So back in those days, if you had a complaint, hey, I think my fuel pump died, no. You don't even have a fuel pump, bro. There isn't one. It's gravity feed. The fuel tank's right here. And then right in through here where I'm flashing the light on, the line goes into a fuel filter and feeds on down to this single barrel basic carburetor. It's actually an updraft. Air goes up kind of at a 90-degree angle, which is kind of common in those days to use updrafts or downdrafts at a weird angle. It's kind of strange. No fuel pump, nothing complicated, just basically using gravity to drip fuel into a carburetor, and it atomizes the fuel into the engine. This is the basic beginning of gasoline engines. Very, very basic.
It's unfortunate with modern gas though, it gets so hot it actually evaporates before it actually gets drop fed that far.
Right, modern ethanol gas, which basically the gas today that's at gas stations, ethanol or not, is not the same gas that your grandpa used in 1950. It's been reformulated, things are different. I don't know the exact changes, but I know in some of these old tractors, the heat from the engine can actually get the gas boiling, and it just boils your gas out while you're driving. Gas used to boil similarly to water, 210, 220. Nowadays, especially with ethanol gas, the boiling point can be 170, 180, which is operating temperature for your engine. So I remember I had an old tractor once. If it was a hot day out and I turned the tractor off, it sounded like a tea kettle. I could literally hear my gas boiling in the gas tank, just like that. I was like, wow, this wasn't a problem when this tractor was new. It definitely is today. This is Hoovy's 1946 Chrysler Town & Country with a straight 8 flathead engine. Really cool old car, but I want to show you guys the next iteration of carburation. So now we're getting into actually some electronics with the carburetor, and also we're no longer gravity feeding fuel, which on the Model A's and Model T's the fuel tank was literally right here, and they just gravity fed it to the engine. But now we got the fuel tanks in the back. We need to find a way to get the fuel from back there up to here, which is a fuel pump right here. Underneath that little shield is actually a fuel pump that runs off of the engine, probably off of the camshaft. And you can see the line, it comes up through here and pumps fuel into this carburetor, which is a downdraft carburetor. It's not 90 degrees, it's just straight down. And this one actually has electronics for the transmission. It's called fluid drive. It can actually do gear shifting and different things based on the input it gets on the electronics off of the carburetor, which is really cool technology for back in 1946. And this big air filter here, we're still doing what's called oil bath. There's no paper filter in there. It's actually oil, engine oil. And the air runs through the oil and filters the air. These are really great, but like we just talked about with modern fuels, there is a problem, which wasn't in 1946, it wasn't a problem, is that the exhaust manifold is right next to the carburetor. Take a look. You can see that they do have a little heat shield here to kind of block some of the heat, but that's not enough with today's gas. Even the heat just soaks right into the carburetor, and this is a fuel bowl where fuel is at, and it literally just boils the gas out. So every time you turn this car off and let it sit for half an hour or an hour, when you come back to start it, this carburetor will be completely empty of fuel. It will literally boil and evaporate out, which means longer crank times. There's so many times I have guys call, I got an old car, and it takes forever to crank after it sits for a little while after I've driven it. And they almost don't believe me. It's like, it's the fuel, man. Today's fuel is trash compared to what they had back then. Oh no, that's not what it is. And finally I convinced them to let me put an electric fuel pump on that primes the system right before they start the engine, and their problem goes away completely. And they're like, I just never thought the gas would be the problem. Yes, it is the problem. So there's one more iteration we're going to show you of a carburetor before we start jumping into fuel injection. Through the different iterations of carburetors throughout the day, they started wanting more power, bigger engines. They started doing 2 barrels, and now this engine here I'll show you has a quadrajet or 4-barrel carburetor. This car didn't originally come with this engine, it came with a different engine. This is actually out of a 70s Cadillac, but it at least has a quadrajet that I can show you how there's some electronics on it, also much more fuel usage. There's 4 barrels instead of 1 or 2 now. Let's take a look. Here you can see a little electronic solenoid that kicks out when the air conditioner is turned on to give it a little bit more throttle. Here we can see there's 2 front barrels that it mainly runs off of, but when you really want the power and you put the foot to the floor, these guys back here will open up. This is the 4 barrels, and it really starts dumping fuel in and gives you more power. Another electronic piece is right here. You can see this wire coming off. This is an electronic choke. So all you have to do when you turn the key on is just hit the gas pedal once. That sets the choke automatically, and it's ready to start. Before we jump over into fuel injection, this is kind of the beginnings of fuel delivery into the engine. So if you have one of these carburetors, or you kind of take your air cleaner off and you see things like this, don't be calling and asking for a fuel injector service or something like that, because you don't have fuel injectors. There could be shops out there that will say, oh yes, we'll sell you one. And there's not even any injectors to clean. So you need to make sure you're kind of familiar. You don't have to fully understand it. You don't need to be a mechanic guru or anything. But just kind of take a glance under and see what you got. Carburetors start to go away in the early 80s on some cars, European cars and things. And really with American cars, it would be the mid to late 80s. You start seeing like on Chevy trucks, you actually seen a badge on the back that said fuel injection. But Chevy actually had in the 50s, with the Corvettes, they had mechanical fuel injection. Here's a picture of one. They call it a fuelie. But it was fuel injection, but with no electronics. It was all mechanically operated, which we're getting ready to show you something very similar as we hop over to a DeLorean. So this actually has a Bosch Jetronic system on it.
Wizard, we don't say those words on here. This is a family channel.
Sorry, that is a curse word, Jetronic. I'm sorry about that. In fact, most shops, including Car Ninja at German Motor Works in Wichita, if you bring him a Jetronic system, he'll say, take your car out of here. It's not happening, bro. Not a lot of people work on these anymore. We won't service them or tear them apart anymore, but we do make adjustments or whatnot. But anyways, back to the car. This was the beginnings of fuel injection for the masses, not just for a special Corvette like Chevy had. This is for everybody. It does have a few little electronic things here or there, but for the most part, the operation of the entire fuel injection system is 100% mechanical. Let me show you kind of what it looks like and how it works. This looks like a car distributor for your spark plugs. It's not. It's a fuel distributor for fuel. Each one of these goes to a cylinder, to an injector. All 6 injectors operate at the same time. They're always running. It's not like one can shut off and the other opens and closes. They all open at the same time. So it's kind of a dumb system. The fuel comes in over here, And then underneath this where it says DMC is an actual metal flap where the air comes into the engine, and as you give it more gas, the flap moves. Vacuum moves the flap up and down, which is connected to this thing, which opens it up and lets more fuel to the injectors. You can see over here there is one little electronic piece called a warm-up regulator. It's used for when the engine is cold. It adds a little bit more fuel and helps it run smoother. But other than that, the rest of the system is mechanical. Here's our injectors. There's one at each port. This is multi-port fuel injection, but it's not sequential. It's all at the same time. So it's not like it does bank 1 or bank 2 or single injectors. It's all 6 all the time. So that's the way. It's kind of antiquated, but it is old. Here is our cold start injector, which when it's really cold, it gives it an extra shot of fuel just to get it started. This actually helps keep it running once it does start.
So now that you've insulted their ears, why don't you tell them why it's such a bad word?
These systems are extremely complicated. They require lots and lots of special equipment to properly set them up, to properly get the fuel metered. You need to have a 5-gas analyzer on the exhaust while it's running to set and get everything set up just right. Now that these are getting on to be 30 and 40 and 50-year-old systems, they sit in someone's garage for 20, 25 years or more. And when that happens, these systems are not tolerant of sitting for that long. There's multiple components. There's fuel accumulator, fuel filter, distributor head, warm-up regulator, the injectors, the fuel pump. There's so many different pieces and parts of the system that are all mechanical, diaphragms and different things like that, that when you let them set that long, you don't just replace 1 or 2 pieces. It's going to be a complete system replacement. Every part of that system is going to be failed or bad now. And it can be thousands. And the frequent thing I always run against with these systems is when they've had it set for so long, is I hadn't planned on putting that kind of money into this car. Okay, well you shouldn't have let it sit for 25 years. I'm sorry. They'll go take it to a few other shops and they'll tell them we don't even work on those, get that out of here. And finally, there's a few shops around, you have to do some searching that will work on these. When you let them set a long time, it's going to take tons of money to sort them out. So they're not popular anymore, people don't want to work on them, or the shops or whatever. But that is the beginning of fuel injection. Back in the day they were pretty good, but not so much anymore. Let's move over to throttle body injection. So as many cars are in the shop right now, we actually don't have anything in it with throttle body injection to show you, but I will show you a few pictures. Here's one of a Chevy truck, what it looks like. It looks like a carburetor basically. It actually will bolt in just like a carburetor, but no longer is just using mechanical types of means to get the fuel into the throat of the engine. There's actually 2 little pods on top that are spraying fuel electronically, and now we have a computer, a control module, an ECM, controlling fuel rate, fuel flow, all kinds of different things, timing on some of the newer ones. We're finally now into the era of computer-controlled electronic fuel injection. These systems were much improved, much simpler than what we just saw on the DeLorean, much easier to fix. But even at that, they ran, they did okay, but they weren't very smooth. The throttle response was slow compared to modern cars today, but it did the job, and they're a pretty good system. They're not so expensive to fix. You typically see these in the mid to late 80s all the way to the early 90s, mid 90s, somewhere around there, 94, 93, it starts to go away and they get into actual fuel injectors that are on the intake, no longer little pods above what looks like a carburetor. But that's pretty much the beginning of electronic fuel injection. Let's head on over to a vehicle that has modern fuel injection that we're used to, where there's fuel injectors, a fuel rail, things of that nature. Let's head on over to the Lotus Evora. So this Lotus actually has a Toyota V6 in it. This is what they came out with, but the way that this engine is angled is actually very easy to see the injector. So let's take a look. So being it's a V6, we can see this bank of cylinders. The other bank is actually underneath the intake. You can't see them. But we've got pressurized fuel coming from the fuel tank that's under 40, 50, 60 psi, depending on what vehicle it is, filling up this black fuel rail with pressure. And then the injectors are electronically operated by a computer with these little wires. They open and close. You can actually hear them when it's running. They go like tick, 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 if you listen to it through a stethoscope or something. But they can open and close longer in duration or even faster, or different ways to get more fuel into the engine. But this is definitely a computer-controlled engine. Everything about it, the timing, the fuel rate, everything is electronic. So now we're getting into engines where we talk about an injector flush. Yes, we could do that on this. It actually has injectors. This is what it looks like. If you look under the hood of your car and you see things that look like that, then it's definitely a fuel-injected car. And we'll show you one more car that has this same system, and then we're going to hop into not the final iteration, but the current one that's being used on a lot of cars today. But let's head on over to Eurasian Bob's Ferrari 348. So at the back of this car we have the Ferrari V8, and we have a lot of electronics and things out in the open. It's very easy to show you some of the ways, not only how the fuel system is operated, but also how it's controlled. Let's take a look at this. So you can see the fuel comes in pressurized, just like I mentioned, into this little blue loop, and then this silver tubular shaped thing is the fuel rail, and you can see that it's connected to injectors. There's 4 on this side and 4 on this side. They're the same style we just saw on the Lotus as far as being electronically controlled injectors with pressurized fuel in the rail right here. Again, 30, 40, maybe 50 psi of fuel. So here we see a mass airflow sensor that actually measures the air going into the engine. This is a throttle position sensor that tells the computer how far open you've just opened the throttle. Then we have an idle motor right here, which actually controls idle air going into the engine. Lots of different electronics now. This is definitely not as simple as that tractor we started out with, is it? These systems started really coming into play in the late 80s, early 90s on some cars, but really became the standard into the early to mid 90s. Pretty much every car that was gasoline had this type of a system with a pressurized fuel rail, with injectors that electronically open and close, and lots of electronics that actually took in data and would measure the fuel based on the data. Now there's a time when we get into 2012, 2014 range, we start seeing what's called direct injection, where we no longer have the injectors spraying into the intake. They're actually spraying directly into the combustion chamber. Here's a picture here. You can see it's no longer spraying as the air is coming in. It sprays right into the cylinder. We actually have a car in the shop that has this system. Let's go take a look. This is the Volkswagen Beetle you guys saw recently in a video. The customer had us do a few more things while it was here, and we're just about finished with the job. But this one actually has direct injection. And basically there's still a fuel pump, just like the fuel injection system we just talked about. There's a fuel pump in the tank pumping 50, 60, 70 psi fuel up to a fuel pump, a second fuel pump. We have 2 fuel pumps now, a low pressure and a high pressure. So let me show you what we got here on this engine. The first fuel pump, or the low pressure pump, is actually in the fuel tank supplying fuel to the high pressure pump, which is ran off the camshaft. It takes 60 or 70 psi fuel pressure and bumps it up to 300. Some cars might be 253. I'm not knowing the exact numbers here. I'm just saying it's somewhere in that range, 350, 400. So here is the actual high pressure pump. This little guy here. This is a duty cycle fuel pressure regulator. It's actually ran off of the camshaft, and it pumps it up to very high pressures, because since we're pumping into the combustion chamber, you're not going to be able to do that with 40 psi. You're going to need a lot more. So right here at the bottom of the high pressure pump is actually a steel line. We don't no longer have flexible little hoses. It's a steel line that curls all the way around and down through here to, it's a fuel rail, just like we've seen on the previous 2 cars, but the injectors go straight into the cylinder head, into the combustion chamber. So here's our intake. We don't have injectors anymore in the intake. They're actually going straight into the cylinder head. This system is very, very good. It's very precise. It atomizes the fuel even better. Better fuel economy, more power. It really is a great system, except for As you can see in this picture, the intake is literally choked up with carbon. So it's very common on these, since there's no longer injectors spraying through the intake and washing the carbon out and cleaning the back of the intake valves. There's nothing there anymore. So all the PCV vapors and things of that are going into the intake. They're not being cleaned anymore with fuel. They're just going straight in through the intake and into the engine. The fuel is sprayed into the combustion chamber now, not in the intake. Which makes it very common to have induction cleaning services, is what it's called. And that's where you actually can remove the intake and scrape the carbon out, or there's services you can do through chemicals and such while the engine's running. It'll actually help clean that out. It's a service you do ever so often to help keep it clean, but once it gets really bad, just like the picture I just showed you, you pretty much have to pull the intake and scrape the carbon out. This is different than the type of chemical you used to buy and pour in your gas tank. Nothing you're going to pour in the gas tank is going to take care of this problem. It has to be addressed at the intake manifold. You really don't see problems with this till you're getting close to 80 or 100,000 miles. You really need to start looking into it to see if it needs to be cleaned, or just have the services done. But although this system is really awesome, it's very, very good, you do have to worry about the direct injection problems with induction cleaning and all that, and the carbon getting into the intake. So with newer engines, when you start adding direct injection, twin turbos on a V6 or just a turbo, they're really pulling some serious power out of smaller engines today based on this new technology. But like I mentioned, there is some issues with induction cleaning and whatnot. So another thing to think about is if you have the previous generation of fuel injection, like we saw on the Ferrari, you probably do not need induction cleaning services. The reason for this video is because I've seen a lot of people get ripped off. Things being sold, services being sold to customers on cars that don't even have that technology that need that particular service. If you have direct injection, you probably will need some induction cleaning services. If you have the standard fuel injection like we just saw on the Lotus or the Ferrari, you don't need those. And the previous systems before that, mechanical fuel injection, you're just going to pretty much have problems all the time. It seems like those things are always having issues all the time because they're old. So with all these cars that we have in the shop today, and the fact that I get to use my magic wizard wand for you guys, definitely wanted to get a video out to kind of clear up what's the difference. Carburetor, throttle body injection, standard fuel injection, direct injection. Now, where will technology go after direct injection, or we're getting into EVs or stuff? I don't know. That is yet to be determined. There's a lot of technologies out there, even completely new engines that are things that we can't even imagine they're coming up with now. I don't know where it's going to go. It's going to be interesting over the next 20 or 30 years to see how things turn out. It's going to be very, very cool to see. Are we going to continue doing gas engines? Are we going to do away with them? I don't know. We'll have to see. But anyways, hopefully this video helps some of you guys out to understand fuel systems and how they work. Make sure to check out all the links in the description. We've got lots of really good links and things to check out, other channels to go check out. Really cool stuff down there. And make sure to hit the subscribe button here because we got many more cool videos to come. Thanks for watching.